Today we will continue looking at potential and kinetic energy. First, let us consider the types of potential energy. The first type of potential energy we are very familiar with at this point. Gravitational potential energy is dependent on mass and height. For example, at the top of a roller coaster, the car has a lot of potential energy. And when you have a hydropower dam, the water at the top of the falls has a lot of potential energy. The second type of potential energy is elastic potential, which is stored due to being stretched or compressed. For example, when a string is compressed or pushed together, it has a lot of potential energy. Same for rubber bands. When rubber bands are stretched out, they have a lot of potential energy. The third type is chemical potential. Chemical potential is stored in bonds between atoms. For example, if you look at fuel, such as gasoline, it has a lot of energy. That's why when you burn gasoline in your car, the car can move. Also, food has potential energy. So you eat food, and that gives you the energy to move, work, play, think, basically anything you need to do in your life. The final type is nuclear potential energy, which is stored in the nucleus of an atom. This is the most concentrated form of energy. It is typically found in nuclear power plants as well as things like atomic bombs. We will come back to topic question 4 later. For now, let's consider topic question 5. What is the law of conservation of energy? The law of conservation of energy states that energy can change forms, but it is never lost. This means that energy can neither be created nor destroyed. Rather, it can only be transformed or transferred from one form to another. An example of this is a roller coaster car that has a lot of potential energy as it sits at the top of the hill. This energy is converted to kinetic energy when the car begins its first drop. The kinetic energy is converted back into potential as the car ascends the second hill. Now, I'd like you to pause the video and watch the kinetic and potential energy in a roller coaster. Please label the empty boxes along the roller coaster track where potential energy and kinetic energy are increasing and decreasing. Eventually, the roller coaster car will not be able to rise up another hill. Why is this? What happens to the energy of the car? Please answer that question in the box provided. Next, we will answer topic question 6. What is energy transformation? So, energy is a strange property of objects that is sometimes easy to see and sometimes it is not. It's kind of like wealth. Sometimes you can tell someone is very rich because they have a lot of things or do exciting things. Similarly, energy is really easy to see when it's making changes happen, sort of like lighting up a light bulb or making a bicycle move or even making music play. Other times, the energy is just being stored somewhere, like in height or in a pulled back rubber band. This is like when wealth is just being stored somewhere, such as money being stored in a bank. Energy transformation is the process of energy changing from one form to another. This transformation is often able to be seen because it produces a change in the object's motion, position, temperature, or appearance. For example, with the roller coaster example we looked at a minute ago, the potential energy, which was stored due to the height of the car, was transformed into kinetic energy of moving the car. This was then transformed back into potential energy partially as the car went up another hill. Since the second hill was shorter than the first, the car had less potential energy than when it started. The process then repeated as the car went down the second hill. The potential energy was also transformed into heat energy due to the friction of the car on the track. We will learn more about other types of energy, such as heat, in the next video.